We're back with this Land Cruiser Prado 120 series, and today we want to address the power window problem. So the customer complaint is that the power windows do not work correctly. The driver's master switch, only 3 out of the 4 buttons work. But on all the doors in the car, all the respective switches work correctly. So let me show you what it's doing. Let's get the key, put it on, and we come here to our master switch. Here is the front drivers, and that one works correctly. And this is the rear right window. That one works correctly. This is the left front window. That one works correctly. But if we hit the rear left window, we've got no action from here. But if you go here on the window switch, we can actuate it. So we can put it down and we can take it up. Okay, that is the issue it has. Now this car has had a litany of parts thrown at it. Let's walk you through it. The power window master switch has been changed. The rear left switch has been changed. The motor inside the window has been changed. And then the fuse box has also been changed. Now, why did they change the fuse box? I'm sure they traced wires from the switches and they found that a couple of them come here, and after hitting and missing all those, they decided, let's change the box. Interesting. So we are tasked with doing this diagnosis correctly. Now, when you face an issue like this, you always need to gather data. My goal for this channel is to teach technicians and car owners that proper diagnostics has got nothing to do with a diagnostic machine. It has all to do with your ability to gather as much data as possible, analyze the data, get evidence from the data, and follow your evidence, and the evidence will lead you to the problem. That is the proper troubleshooting technique. A scan tool will not do that for you. AI will not do that for you. You need a mind that is good for troubleshooting. And that is why we are paid to do things like this. So let's see where to start. What you need to understand about these systems from 2002 onwards, these are not just normal switches. This is actually a multiplexing computer. These switches, all they do is to send a command down a network onto the body computer, and the body computer is the one that relays information back to the respective door to tell it either roll down or roll up the door. So we need to find out, is this working correctly? Because everything starts from here. If this doesn't work correctly, nothing else we do on the doors will be of any use. So what I want to do is to get a scan tool, and we're going to plug in a scan tool, and I want to read the data from this if we have access to it. And I want to see if when I activate my switches, the data is going to change on the scan tool. So scan tool coming up next. Today we're going to use a ThinkDiag for our scanning. Let's go to All System Diagnostics and look for Toyota. Oh, and put the key on. (16-pin) DLC Japan. Land Cruiser Prado, and that's correct. And since I don't know which system it is, we'll do a health report and see which systems populate and take it from there. Right, we're done with scanning, and we have a driver's door computer. Let's go into that. Let's read the data stream, and let's see what we have. So we've got the auto switches. All right, so now all our switches are off, and what we're going to do is hit a switch that works and see what happens here, and then hit the switch that doesn't work and see what happens here. So let's go to the power window auto switch. That's the driver's side. That's this one here, and we're going to just hold it down and look at the data, and you can see it changes state from off to on. I'm going to let go of it, and it goes off, and I'm going to go up as well. Hold it up, you can see it changes to on, and I let go of it, changes to off. So that is the proper way the switch is supposed to operate. Now let's go to our offending switch, and that is this one, which doesn't work. We're going to press it down and hold it, and look at that. We have the rear left door power window auto switch status is on. Let me let go of the switch, and it goes off, and there's a delay. Obviously, these old systems, the communication is quite slow. Let's do the same thing in the upwards, and there we see we are on. Guys, a quick test like that should tell you there's nothing wrong with the master switch. You don't touch it. Why would you replace this? And yet you have got actuation command that is recognized by your scanner. That's all this does. So we are done. There's nothing wrong with our switch. So our next thing to do is let's go to a wiring diagram and see how these windows are commanded, and we'll get more direction from there. So here we are in the service manual. Let's go to the wiring diagram. Let's do a quick translation here. Body and electrical. Power window system. And that is our schematic. This is in Japanese. I'd already done a translation previously, and that's this one here. So let's go to our motor that doesn't work right, and that is the rear left hand. So here we have the power window motor. That is this one, and then it's connected to the power window switch, and it has got different connections. So there's this two for the motor up and down, then there are these ones, Hall IC1, Hall IC2. I don't know what those are yet, we'll see later. And also this one, or VCC. So this is VCC, some kind of voltage supply, either 5 volts or 9 volts. So that is a voltage supply down to the Hall ICs. But what do these do? Hall ICs are usually sensors that are for like camshaft sensor, crankshaft sensor, basically position sensors. Wait, I think I know what these are. I think these are the ones that detect whether the window is going up and down and how far. The Hall ICs, okay. And then this is a ground to the motor. Then we have our master switch. We have 2 grounds, and then we've got permanent battery power on this line here. And then there's this line that comes across, and it bridges to all the switches. And what is that line? Well, let's see what it is. If you notice, up here, we've got permanent battery power to this switch. Permanent battery power is also on this switch here. Then this switch has got its permanent battery power here, BDR. And this switch has got the BDR permanent battery power. But only the master switch has got the ignition key on power, which is coming from this line. So how do the rest of the switches know that we've keyed on? Well, it gets it from this, KOF. I don't know what KOF stands for, but I'll call it key on function. And it's the one that distributes the key on to all these switches. So we know what that is for. Then there's this line RX. RX bridges in the body computer, which is a fuse box, to all the switches again. Now, I will tell you what that is. When you see MPX, MPX for Toyota is the multiplex connection communication line. Basically, it's a LIN bus. So you should see a square wave communication on this line. So it's a communication line, a data communication line to these switches. That's what that is. All right, so pretty simple. The only thing we don't know is what these really are for, but we can actually go to that switch and test for this. So let's go to the power window passenger switch, rear right, rear left, and we're going to test this. Put this on channel 1, I want to see 12 volts here. Put this on channel 2, I want to see 12 volts here when you put key on. And then I want to see a multiplex, a LIN bus communication on this line. And then we're going to test our grounds. If all those are good, then we'll carry on from there. Here are our connections. You got the blue channel, that's permanent battery power. And then the red channel is the ignition key on power supply. Then the green channel is our LIN bus, which is our multiplex communication line. And we're connected to the picoscope. Let's go and see what is going on. All right, we are back in the car. I've closed my doors because I want my body computer to go to sleep, and also my ignition key is out of the ignition cylinder. Now we're going to come here and start the scope. And the first thing I want to see is whether I have battery voltage. So that blue channel is the permanent battery power. That red one is the ignition key power on the switch. And this one is the LIN bus, which is my multiplex communication. So right off the bat, I see on the green, on the blue channel, that I have 12.7 volts, 12.6 volts on that. So my battery power is good. I like that. Now we're going to come here and take the key, and I'll just slot it in the ignition in there. And that turns my LIN bus on. And what I'm going to do is pause it, and let's analyze. So look at this LIN bus. When you see a repeated pattern like this, usually means standby mode. So there's nothing wrong with that LIN. That's healthy. So that in itself tells me that this was unnecessary to change the computer. Knowledge of diagnostics. We've already eliminated two things right now. We've eliminated the computer. We've eliminated the master switch. Let's keep going. Let's come back here. And what I want to see is my LIN activity okay? Can the command be sent over the network? So let me put the key on here. So the key is on. So my LIN is active. And check this out. Let me pause this. Look at this line, ignition key on, power is good. All right. So our 3 lines are good, but I'm interested to see my LIN activity if there's going to be a change when I press the switches. So let me start the scope again. And what I want to do is to come here and hit the switch that was not working. This should trigger a different signal on the network. So I'm just going to press it and let go. Here we go. Press, let go, and come here, pause this. Now, will I be able to see a difference by scrolling just like this? Sometimes you can, sometimes you can't. Let's first see. So this was the idle mode. And I don't even know what the idle mode is. So my eyes are not too good in doing that. So what I'm going to do is to come here and use the power of this scope. Let's take our math channel. And we're going to plot the frequency of C. Which is here. Okay, let's cancel that. There. And then you wait for the frequency to come up. Now that is too high. My scales are not set correctly. So let me come here to math channels, and we are going to drop this to, let's go to 600. Finish. And okay. All right. Now we see it. Now check this out. You see this? We have the idle mode here, and then there's a change right here. So I'm going to come here, do this, and we can see a change there. So our LIN bus is able to respond and transmit the message of that switch, just like our scanner told us. And you can see here, this is the idle mode. And here we can see a difference in command. That is pretty cool. So further confirms that the switch has no issues with it. Let me put off my math channel. It takes a lot of processing power. Okay. So right now we have everything, at least in these 3 lines, that switch needs to function, but we are not activating the motor from the command on the network. So let's come back here to our wiring diagram. This is fine, this is fine, this is fine. Now we need to interrogate our 2 grounds here. Let's just eliminate those very quick, and then we come to these 3 lines. All right, now we're going to test the grounds. There are 2 grounds, and they are both on the white and black wire. So this is one, this is the other one. So I've got my test light connected to battery positive, and this is our first one. And we have a good ground there, nice bright test light. And this is our second ground here, and also we have a good, nice and bright test light. Okay. Now we need to interrogate the lines that are going to the motor itself. Now we know the motor is working because it works with this switch. But why is the network unable to switch on the motor? Because that's what's happening. We have network command here, but the network is unable to switch on and off this motor. I'm interested to see what those Hall ICs are. So let me probe those 3 lines, the VCC and the 2 Hall ICs, and then we're going to raise the window up and down and see what happens with those lines, then take it from there. So this is what I'm talking about. There's PLS1, PLS2, and VCC. So VCC I already know is some type of power supply to these 2 Hall ICs. And then there is this ground here. Actually, we can just test this ground right at the switch very quickly. So what are these? I think these are position sensors or some type of velocity sensors for these windows. And that's the only thing. Or it's revolution sensors for the motor. I don't know what else they could be. There's no other reason why you should have a Hall IC in here. Remember, these are sensors that sense motion. The only motion here that's moving is this. So it's some kind of revolution sensor for the motor. Or they do something else. I don't know. So let's go here to PLS1, PLS2, and VCC. And then we probe. Actually, we'll also probe the ground here. So channel 1, channel 2, channel 3, and channel 4. And then we raise the window up and down and see what we get on the scope. All right, we made our connections. Channel 1 is Hall IC 1. Channel 2 is Hall IC 2. Channel 3 is VCC. And channel 4 is SGND, which I suspect is a signal ground for those 2 IC sensors in there. So what I'm going to do is go put the key on and then raise and lower this window. And then we see what we have on the scope. The key is on and the scope is running. So the first thing I have to do is to raise or lower the window. Okay, that's lowered. And now let me raise the window. And that's raised. Now let's pause the scope. And let's analyze that. So what we have is a mirror on all these lines. Let me put them on the same axial plane here. So let me drop that one here. And let me raise this one. Which one is that? The green one. Oh, here. Let me raise the green one up. And these lines are basically identical. The only thing is the VCC line seems to be slightly higher than the others, but it's completely a mirror image of each other. What is that? Is that normal? I don't know. That to me doesn't make any sense. Let me separate this again. Do we have a broken motor here? Do you have bad sensors in that motor? Well, what we need to see is first let me save this. Okay, it doesn't appear that this motor is giving any feedback, but I don't know what is supposed to be here. All I can tell you is that the ground here is good, but what's happening with Hall IC 1 and 2? The VCC is there because the VCC is the power supply, and that's fine. But Hall IC 1 and 2 don't seem to be doing anything. They just follow the VCC. And since the VCC is higher, that suggests to me that it is sending the power supply into the Hall IC, and then it's returning them back on these 2 lines. That's why they are lower. Now I tell you what, these are identical circuits on all these doors. So let me go to the front left door, and I'm going to connect this and take the same capture, rolling the window up and down, and then I see what the result is. I need to make sense of this circuit for me to make a diagnostic call. Here we are in the front window, left window, and same connections. Now let me drop the window. I've seen the problem. Let me raise the window. And let's pause the scope. And we are done. I'm going to ask you, what is wrong with this car? That capture there, compared with the other one, tells you everything you need to know. So pause the video here if you do not want me to tell you, and let's see if you're on the same page. What is wrong with this car? Okay, let me tell you what's wrong with this. We have a bad motor in the rear left door. Let's analyze this capture here, and I'll tell you why I'm saying that. First, let me save this. All right, now let's analyze this capture. Let's zoom in here and check that out. Hall IC1 and Hall IC2 are Hall effect sensors, and they are speed sensors. So these ones detect the speed of the motor. That is so cool. So Hall IC1 and 2 in the rear left door motor, they're bad. Why are they two of them? I think it's for redundancy, because you need to have these two for that motor to work. The question is, why do we have speed sensors in a window motor? I'll tell you what the answer is. The answer is, there is probably an anti-pinch mechanism in this window, and I can test it right now. So let me come here and open the window. So it's down. I'm going to put my hand here, and we're going to see what this will do. So let me raise it and put my hand here. Exactly. Now let me do that while taking the picoscope capture, and then explain to you why this anti-pinch function would work. So let me take that window down, come here, and do that. Let's raise it, and let's pause it here. That is why you have speed sensors. So what the computer is doing is monitoring. Let me zoom out a bit here. I'm a bit too far in. Oh, that is worse. Out. So what the computer is doing is monitoring the speed of the motor. And when it sees the speed of the motor slow down before it continues, because these are high torque motors, you can hurt someone. An adult maybe not, but a child definitely will do a lot of harm to a child's hand. So when the computer sees the velocity of the motor slow down, it backs off the motor and reverses the direction and then stops it. And we can do this. Let's take a math channel, and we'll take the frequency, not the frequency of A, yeah, the frequency of A, but let me drop this and take it to, no, that's a color. Drop this to 600. And I want you to see the frequency here. So let's take this up. You see in this area here, this is where I put my hand in. The window is going up fine, it's a constant velocity, and then suddenly the computer senses, hey, the velocity is dropping. When it sees the velocity dropping like this, the frequency drop, it immediately knows that there is some kind of obstruction and reverses the direction of that window. So this is good. Now I know why this is not working. Since the speed sensors back here are not working, what it simply means is the automatic function, which is what the driver switch gives, is completely disabled. So this rear window needs a new motor. Now you may ask, but the motor was replaced. So what? I'm not the one who replaced it. I don't know if it was really replaced. And even if it was replaced, I do not care. My scope does not lie. This motor here does not have a functional speed sensor inside. So it's unusable. I've been in a situation where someone has replaced or supposedly replaced a very expensive part. I come and I do a diagnosis, then I tell them, hey, this part is bad. And they flip out at me. And I tell them, look, I'm telling you this part is bad. If you replaced it, you either replaced it with a bad motor or it wasn't replaced at all. Those are the only two options. But I'm confident in my diagnosis that motor is bad. We need to get a replacement motor for this door. Let's go to the Toyota EPC and just check out the part number. So this is where we are. Left hand, rear motor, rear window regulator and hinge, and we are on the left hand. And that part number is 85710-58010. So I'm going to let the owner know about this, and then we're going to order it from Japan and let it come, install it, and call this a day. But before we do this, I know some of you are going to be very curious. I do know somebody in town who sells used parts. I'm not a fan of used parts. I use them sometimes, but not electrical parts. But this guy does have access to these parts, and he gives me to test at a very low fee. So let me call him up and have one of his delivery boys deliver a motor to me, and then we're going to install it in this door and test it, because I'm also curious to know how this will be resolved. This is a problem that has lasted several years, close to 3 years for this owner. I want to see this window function. So let me go and call this guy and then see if it can be delivered. All right, I've taken out the motor and the regulator from the car, and this is the motor that has just been delivered to me. And I will tell you why I do not like buying used parts from local vendors. So that in a minute. Let's first look at this. So this is the motor, and I want us to observe our part number. What do you see? That is the wrong part number that was installed in this car. So 100% confirmed, this is the wrong motor. So I don't think the problem is with the position sensors. I don't think this motor has position sensors inside. So let's see the part number that has come. This one is the correct part number, as you can see there. 55010. Now, let me show you why I do not like buying parts from local parts vendors. If I buy used parts, I just take the time and import them from Japan. Why? The culture in Japan is such that people there are just more honest. If they tell you a part is grade A or B or C, that's what it's going to be. I want you to observe this part. First of all, look at this. The boot around the connector housing has been damaged. See that? That's how the boot is supposed to look like. This is how this one looks like. That is a sound dampener. It dampens the sound from the motor going into the door, and it is small things like this that cause your car to be progressively more and more noisy. But I want you to look at the seam here. You see this? Some prying action has occurred on this motor over there, which means this motor has been opened before and has been tampered with inside. Is it going to work? I don't know. And if it works, will it work long term? Probably not. So when you throw a part in the trash, it's going to find its way to someone who's going to try to overhaul it and then put it back in the market. Now, if they did a good job overhauling it, I would be okay, but these guys really do a bad job when they do that. So this is why I do not like local parts vendors. There's just a trust issue that I have, and people here are not very trustworthy. I don't know how it is in your countries, but in Kenya, man, be careful with local used parts vendors. So, enough talking. Let's transfer this motor onto that regulator, and then, actually, before we transfer the motor, why don't we just take this as it is, rather than waste my time? Let's put it inside the car, connect it, and then attach our 2 speed sensors, and then see if we can get a speed sensor output from this thing. Okay, let's install our motor. Here we go. And I've already connected my 2 speed sensor channels here, channel A and B. Scope is running. So let me put this in view here. So let's go to the downward direction. And our speed sensors are working in the downward direction. Very good. Let's stop that. Let's go to the upward direction. Working again in the upward direction. Let's pause that. Let's analyze it. Okay, let's open that up. And that's beautiful. Look at that. Nice speed sensor signal. It's consistent. No dropouts. No missing teeth. Nice and steady. That's in the downward direction. Let's go to the upward direction. And that's in the upward direction. Nice and steady as well. I like it. So this motor is working. So what we're going to do is install it in the door. It's not very hard to do this. It takes like 2 minutes. We'll bolt it up, put the regulator, and then program it up and down just by resetting it with the switch all the way down, then all the way up. Then now we're going to go to the master switch and hit the down button and see if we have window action. Door is back together. Now let us reset the window. The key is on. So we take it all the way down. Hold it for 2 seconds. And take it all the way up. Hold it for 2 seconds. Nice. Now the window is reset. Let's go to the master switch and see whether we have window control now on this door. Okay, here we go. So let's see if we work, and we go. And what do you know? There's our window going down. Let's bring it back up. And it's up. And there we have a nice reflection of the picoscope in the window. That's it, guys. We are done. Wow. Nice diagnosis. I love this one. I've learned a lot about the window switches and the window motors. When you see motors with the Hall effect speed sensors, they are for anti-pinch control. And that is really, really cool. Now, guys, part numbers exist for a reason. Here in Kenya, I see a lot of shenanigans happening. People think that just because one part looks like another, you can just interchange them. You are in for a rude shock, and sometimes it can be catastrophic. I did an engine one time where the engine was changed and the engine computer was also changed, but the computer that was put in was for just 1 year above the one that was taken out in model, and the part numbers were different, but the connectors were exactly the same and the engines were exactly the same. But guess what? The input outputs were different. They were not the same. So they ended up blowing the computer because one input was for a relay control, and in the computer they put in, it was a 12-volt output. So you sent 12 volts right into a relay control ground, and it blew that computer up. Part numbers exist for a reason. Do not think that these manufacturers are stupid. They just don't have anything to do. They're just randomly writing part numbers down for no reason. They are there for a reason. After seeing that the part number of this motor that we took out was different, I am convinced that it doesn't have bad speed sensors. It simply doesn't have speed sensors. And another way I know that is there are 2 speed sensors in there. What's the likelihood that 2 speed sensors go out at the same time? Highly unlikely. The more plausible explanation is that part number doesn't have anti-pinch control and doesn't have the speed sensors. But they look exactly the same when you look at them physically. Well, that's it. Another one for the books. And guys, I hope you understand the value of good diagnostics. Intelligent diagnostics is where the money is. Until next time.